So for absolute value inequalities, it goes along the same lines as far as having to be negative and positive values in there to get out that positive value. And similar to compound inequalities, there are two possibilities. There's the or inequality in the case of the and. So if we look at this, we did absolute value equations, and with that, your two solutions for x equaling 1 could be x equaling -1 or x equaling +1. Those are your two answers. Let's try to write that a little neater. Equals 1 and x equals -1. So if those are your two solutions, that's it. -1 and +1. So if you're trying to graph it, you would say, okay, that's my solution. That's my solution. There are two solutions. But for an inequality, just like when we talked about the other day, there's an infinite number. It's not just one value. It's a range of values. So if we go back here and say, okay, well, x is greater than or greater than 1. This is greater, and this is going to stand for your or. So whenever you see a greater or greater than equal to, your inequalities should shade out. But if we solve this, if we tried to break this up into our two inequalities, or our two solutions, we would have x is greater than 1 or x is less than -1. What happens with inequalities is when you split it and you make that second inequality a negative, just like when you divide or multiply by a negative, you have to flip that sign. So you keep the original one, x is greater than 1, then you make it negative and switch. So if you guys are trying to graph this, greater than +1 but less than -1, it's showing that that's where our solution is stopping, but it actually continues out. So all of those values, fractions, decimals, all of those numbers that are included in that range could be a solution for that inequality. Now, if you see a less than, that's going to be your and they're always going to shade in. So ors are out and ands are in, if you can remember that. So if you guys were trying to split this into two inequalities, you would have the original, which is x is less than 1, and flip and negative. So less than 1, but greater than greater than -1. So if you guys were putting that on a number line, -1, +1, but they're greater than negative, less than +1. So when you guys are doing this, that's what your solutions look like. So again, the inequalities, a range, an equation is just one or two solutions. It's not a range of solutions. So as you guys are doing this, you have the absolute value of k, and these are just some side notes. It says the absolute value of x equals k is the same as what we set up above, x being positive k or x being negative k. Inequalities, break it up into x is greater than k, x is less than, flip your sign, negative k, and x is less than k, keep the original, flip, and negative. So those and inequalities, guys, so that last one, you can always write it as one large inequality instead of having it as two separate. So instead of writing it, okay, it's less than k, but it's greater than -k, we would just put x in the middle, and your carets, guys, will always point to the left in this compound inequality when you're setting it up or you're writing it. So x is in between negative and positive k. Your carets always point to the left. That's a good way to always check yourself, as long as your values are written from smallest to highest, negative to positive. All right, I'm going to do another example. So number 3 will be done. And then I'm also going to do let's do number 8. This is example number 3 from your guys' notes. I just wanted to do one more with you where the absolute value was not by itself on the left-hand side. You guys can't split the inequality into 2 until this part, the absolute value part, is by itself. So what you need to do is get rid of this minus 5 first and then split it up. So if you have something minus 5, how would you move it to the other side? We would need to add 5. So then you end up with the absolute value by itself on the left-hand side, and 8 plus 5 is 13. But you have to get that absolute value part by itself first. Now, we can go ahead and split it up. So, 3x plus 2 is less than or equal to 13, and 3x plus 2 is greater than or equal to negative. Switch your inequality, switch your sign. And now we can solve for both of these. So, subtract 2, subtract 2. And it looks like we're going to get a fraction, but that's okay. So it looks like for the first one we get x is less than or equal to 11 thirds. Which, if you guys divide that out and actually get the decimal for it, it should be 3.6. So, now we have to solve your second inequality. So you're going to do the same steps, but because you have a negative number, you should get a different solution. So we get 3x is greater than or equal to negative 15. Divide by 3. And get x is greater than or equal to negative 15 divided by 3, which is negative 5. So those would be your 2 solutions for this inequality. So again, get the inequality or the absolute value part by itself. So this one's a little tricky because it's a fraction, but you start with the absolute value of 4b minus 3. That absolute value is over 6. That whole thing, that whole fraction is greater than or equal to 3. So here, if your absolute value, 4b minus 3, is the absolute value, that's the part you're trying to get by itself, it's over 6. It's being divided by 6. So, if you guys are trying to eliminate that part because it's not part of the absolute value, and whenever you're trying to get rid of a fraction, guys, you want to multiply by denominator. That's just a good note to remember. So if we multiply both sides by 6, the 6's will cancel, and 3 times 6 is 18. Now the only thing on the left-hand side is your absolute value, and you can break it up into both inequalities. So you have 4b minus 3 is greater than or equal to 18. That's your original. And then you flip your inequality and change the sign. Don't flip anything on the left-hand side, only flip the right-hand side value. and then you just solve. So add 3, you get 4b equals 21. And again, don't think you're wrong if you get a fraction, because it's okay. Or a decimal. I'm just going to keep it as a fraction. And I lost my inequality sign. That should be greater than or equal to 21/4. So there's my first value. And then we solve for our second value. Add 3. 4b is less than or equal to -15. Divide both sides by 4. So our two solutions here, or our range for our solution, is going to be greater than 21/4 or less than -15/4. And it doesn't ask you to graph them on the number line, so you don't have to worry about doing that. It just wants your inequality. No graphing necessary. So go ahead, try the rest of those examples, and if you get stuck, let me know.